Okay, so I want you to look around the room you're in right now.
Just take a quick scan.
Yeah, look at your phone or your desk, even the coffee in your hand. We just have this deeply ingrained belief. It's almost like the operating system of our brains at this point.
That everything is limited.
Exactly, that there's only so much lithium for batteries, only so much arable land to grow food on, only so much time in the day. Scarcity is basically the default setting of reality for us. It's the water we swim in.
Well, it is certainly the fundamental assumption of modern economics.
Mm-hmm.
I mean, the entire concept of supply and demand only exists because supply is assumed to be limited.
Right. But I've been reading through this stack of research we have for today's deep dive. It's essentially this blueprint for a totally new society. And it opens with a thesis that honestly made me roll my eyes a bit at first.
It's a very bold opener.
It really is. It explicitly says scarcity is not a thermodynamic inevitability. It is artificial.
Which is a heavy claim to make right out of the gate.
Yeah, it sounds like a conspiracy theory, like, the government is hiding an infinite sandwich machine or something. But as I actually got into the technical details of the source material, it started to feel a lot less like a manifesto and a lot more like an engineering schematic.
And I think that's the key distinction here.
Mm.
The source material isn't arguing that we can break the laws of physics. Not at all. It's arguing that we are currently confusing social friction with physical limits.
Interesting way to put it.
Right, because it suggests that if you look strictly at the atoms and the energy available on Earth right now, we actually have everything we need to live in a state of radical abundance. We just haven't organized ourselves to unlock it yet.
And just to be super clear for everyone listening, we aren't talking about some sci-fi utopia 1,000 years from now where we all live in floating clouds.
No, definitely not.
This framework claims we could transition to a post-scarcity society in roughly 50 years. That is within a lifetime.
Precisely. And what makes this deep dive so fascinating is that it doesn't rely on magic or unknown science. It relies on three very specific pillars working together.
Which are energy abundance, decentralized production, and mass education.
Exactly. And the argument is that if you get these three things right, the cost of living essentially collapses to near zero.
So the mission today is to stress test this blueprint. We want to see if the math actually holds up or if this is just wishful thinking. Because honestly, when I see phrases like infinite abundance, my scam detector goes off immediately.
As it absolutely should. But let's look at the physics.
Okay, let's start with the engine of this hypothetical machine. The first pillar. The source claims energy is the ultimate unlock for everything else. Why is energy the main bottleneck?
Because if you have enough energy, waste literally ceases to exist.
Wait, what do you mean by that?
This is a crucial concept in the text. We tend to think of waste, plastic bottles, scrap metal, even CO2 in the atmosphere as garbage. But in physics, there is no such thing as garbage. There are just atoms that are arranged in a way we don't currently want.
Right, so a plastic bottle is just carbon and hydrogen stuck together in a specific pattern.
Exactly. And if you have near-limitless energy, you can break those chemical bonds and rearrange those atoms back into something useful. You can turn raw sewage into pristine drinking water. You can turn scrap plastic into high-grade 3D printer filament.
The alchemy of just brute forcing atoms apart.
Basically, yes. The source describes a closed-loop system where you recycle or upcycle absolutely everything. There are no landfills in this model.
But that requires a massive amount of power. I mean, recycling as we do it today is highly energy intensive. We can barely keep the lights on during a summer heat wave as it is.
And that is exactly why the blueprint is so incredibly dismissive of our current energy grid. It argues that wind and solar, while they're great for certain applications, they just aren't dense enough for this specific vision of heavy industrial recycling at a global scale.
So it pivots to nuclear.
It pivots hard to nuclear.
And this is where people usually get very nervous. We hear nuclear and we immediately think of Chernobyl or Fukushima. We think of massive cooling towers and giant exclusion zones.
Which is why the text is very specific here. It points to small modular reactors,
Yes.
SMRs. This is a completely different beast than the legacy plants we built in the 70s.
How so? Think about the nuclear plants you see in movies with the massive concrete domes and huge customized infrastructure built on site.
Right. SMRs aren't built like that. They are built in factories. They are modular.
Meaning what exactly? Like Lego bricks?
More like shipping containers. You build them on a standardized assembly line, you put them on a truck, and you drive them to wherever they are needed. Companies like Copenhagen Atomics, NoScale, TerraPower, and X Energy are all actively working on these right now.
Oh, okay, so they're smaller and easier to deploy.
Yes, and specifically the text highlights molten salt designs for these reactors.
Wait, explain that because I'm not a nuclear physicist. How does molten salt make a reactor safer?
Well, in a traditional legacy reactor, you have solid fuel rods, and you have to constantly pump water over them to keep them cool. If a pump fails, the water boils away, the fuel gets too hot, it melts, and you have a very bad day.
A meltdown.
Exactly. But in a molten salt reactor, the uranium fuel is actually dissolved into liquid salt. It is already a liquid.
Oh, I see.
So if the power goes out completely, there's no water to boil off. Instead, a frozen plug at the bottom of the reactor just melts, and gravity drains the fluid into a heavily shielded underground dump tank.
Where it just cools down.
Right? It cools and solidifies naturally. It is a physics-based safety switch. It doesn't rely on a computer or a human operator to push a button. Gravity does the work.
So it literally can't melt down because it's already melted.
Essentially, yes.
Duh.
And because these units are so small and operate at such high temperatures, you can place them right next to industrial centers. You combine this continuous baseload power with LTO lithium titanate oxide batteries to smooth out any spikes in demand.
And suddenly you have high-density 24/7 power that doesn't take up much space.
Exactly.
That space issue is actually really interesting to me. Usually when we think of a new industrial revolution, we imagine smokestacks covering the horizon. We imagine nature just getting paved over with concrete.
But this blueprint argues the exact opposite. It introduces this concept of GB factories or gigabyte factories.
Gigabyte, like a computer hard drive?
Yeah, as a metaphor for density. Because SMRs are so energy dense, and because the manufacturing tech is so compact, you could theoretically run the entire global industrial infrastructure on a land footprint of just hundreds of thousands of acres.
Which on a planetary scale is basically a postage stamp.
It really is. Instead of sprawling industrial agriculture and massive open-pit mines, you condense the extraction and production into these ultra-high efficiency hubs. And you leave the rest of the planet alone. You give it back to nature.
Okay, so let's assume for a second we actually solve the energy problem. We have the SMRs, we have the molten salt, we have the batteries. We have the power to desalinate ocean water directly, which the text points out basically solves the global water crisis overnight.
It does.
And we can completely recycle all our waste back into raw materials. But we still need to actually make the stuff we need to live. Having a giant block of recycled aluminum is great, but I can't drive a block of aluminum to the grocery store.
Which leads us perfectly into the second pillar, the microfactory revolution.
Right. Now, when you say factory, I am still picturing a classic Ford assembly line. Giant robotic arms doing one specific motion, sparks flying everywhere, thousands of workers on a massive floor.
The source argues that entire model is obsolete. That is the centralized model. You build one massive factory in one country, you make 10 million identical widgets, and then you burn fossil fuels to ship them across the ocean.
So what's the alternative?
Decentralized production. Moving from the centralized grid to the local garage or the neighborhood workshop. And the absolute star of this show is the CNC machine.
Computer numerical control.
Right. But we aren't talking about the basic 2D routers you might have seen in a high school woodshop. The text heavily focuses on advanced 5-axis, 9-axis, and even 9+axis CNC machines.
Okay, I know what a 3-axis machine is. It moves X, Y, and Z, left, right, up, and down. What on earth is a 9-axis machine doing?
It's articulating the cutting tool and the raw material part simultaneously across multiple rotational planes. It can reach around corners, it can undercut, it can sculpt incredibly complex internal geometries, all in a single setup.
So it's basically doing things human hands could never do.
Exactly. A 9-axis machine can essentially take a solid block of titanium and carve a fully functional complex engine part out of it with absolute laser precision without a human ever having to stop and reposition the metal piece.
So it's like a master sculptor that never gets tired, but here is the snag with that. Those machines currently cost millions of dollars. I actually looked it up before we started. A high-end multi-axis machine is not something you just buy for a weekend hobby. It's a massive corporate capital investment.
Currently, yes, you are right.
Yeah.
But the source explicitly lists an economic goal here, reducing the cost of these machines by 90%. The aim is to take a machine that costs $3 million today and get it down to the $50,000 to $200,000 range.
Okay, but $50,000 is still a lot of money. That's the price of a luxury car. Most people don't have that lying around.
True. But for a local community, a cooperative, or a small business, that price point is completely accessible. Look at it this way. If a neighborhood of 50 families pools their resources together, that's just $1,000 each.
Oh, wow.
Suddenly, that neighborhood completely owns the means to produce their own car parts, their own kitchen appliances, their own farming tools.
It effectively democratizes the entire global supply chain.
Exactly.
Right.
But it entirely relies on open source IP to work.
Right, because if you have the machine but you aren't allowed to download the blueprints,
Then the machine is just an expensive paperweight. If the design files for the products are proprietary, say you can't download the file to print a replacement gear for your tractor because the manufacturer locked the software, it fails. The text emphasizes that the instruction sets and the CAD files must be open or publicly owned.
and this leads right into that concept they called the emergent effect. I really liked this part of the reading. It felt very biological.
It's a perfect analogy. Think of a massive ant colony. No single individual ant knows how to build the mound. There's no ant architect holding a blueprint.
Right, they aren't having planning meetings.
Yeah, each ant just follows very simple, localized rules. But together they build this massive structure with air conditioning, nurseries, and complex waste disposal systems.
So translating that to human production, you don't need a CEO in a high-rise office telling everyone what to make or how many to ship.
Correct. If you have millions of people around the world with access to these microfactories and open source designs, you get a total explosion of rapid innovation. Let's say someone in Ohio figures out a slightly better way to print a water pump impeller. They upload the new design.
And then anyone can grab it.
10 minutes later, someone in Kenya downloads it, they tweak it slightly to better handle their specific local water conditions, and they upload version 2. The global productivity is exponentially amplified because you have millions of decentralized brains working on the same problem simultaneously without needing bureaucratic permission.
So it is basically the Linux open source software model, but applied to physical, real-world stuff.
Ideally, yes, that is the vision.
But here's the big but that I just couldn't get past while I was reading this. Giving everyone a 9-axis CNC machine sounds like a complete recipe for disaster if they don't actually know how to use it.
Very true.
I mean, I can barely assemble flat-pack furniture with the instruction manual right in front of me. You put me in front of a 9-axis industrial lathe, and I am probably going to lose a finger.
Or you'll crash the machine in 5 minutes and destroy a $50,000 tool.
Yeah.
You are absolutely right. The physical hardware is completely useless without the proper software running in the human operator's brain.
Which brings us to pillar 3. The human element.
The education piece.
And this isn't just a standard push for STEM or learning to code, is it? The proposal here gets pretty esoteric.
It really does.
Yeah.
It talks about using cognitive science principles to fundamentally retrain how we as humans actually think. It specifically mentions implementing a, quote, Lojban-inspired structure for logic and reasoning.
Okay, pause right there. Lojban. You are telling me that to fix the global economy, we all need to sit down and learn a made-up language.
It sounds totally wild, right?
Yeah.
But think about how we normally talk to each other. If I say to you, I'm fine, that could mean I'm happy. It could mean I'm sick, but I don't want to complain. Or it could mean I'm mad at you and I want you leaving me alone.
Right. Natural language is incredibly messy. It's full of nuance and ambiguity.
Exactly. It is great for writing poetry, but it's terrible for programming. Machines, specifically these highly complex multi-axis CNC machines, hate messy instructions. Lojban is an actual constructed language that was specifically designed to be syntactically unambiguous.
So there's only one way to interpret a sentence.
Yes. Now, the idea isn't necessarily that everyone walks around speaking Lojban at the dinner table. It's that the structure of our early education system should teach people to parse information with that level of extreme clarity.
So it's like installing strict syntax rules directly into the human brain.
Yes. It trains you to think much more like a computer programmer. Strictly logical, direct cause and effect. If you want a regular person to master running a 9-axis machine in a few months,
Right.
rather than needing a 10-year apprenticeship,
Yeah.
you have to remove all the fuzziness from their problem-solving processes.
Okay, so we have the clean energy, we have the decentralized machines, and we have the cognitive brain training. But the source material does something really interesting right around here. It completely stops looking forward, and it looks backward in time.
Yes.
It presents this historical what-if scenario involving the 1950s that I actually found kind of heartbreaking.
Honestly, this was the most compelling part of the entire analysis for me. It argues that we actually missed a massive off-ramp to post-scarcity decades ago.
Walk us through the math on this, because they call it the 5-cent experiment. And when I read it quickly, I thought, there is absolutely no way that math adds up.
Let's break it down slowly. Go back in time to 1950, post-World War II America. The industrial manufacturing capacity is absolutely huge. The text says, imagine if the poorest 25% of the population, the working poor, contributed just 5 cents per person per month into a collective investment trust.
Wait, so 5 cents? A nickel.
A single nickel.
A month. That's it.
That's it. That is 60 cents a year per person.
You can't buy anything with that, even in 1950.
Individually, no.
Yeah.
You can't. But you pool it. You have tens of millions of people contributing that nickel. And then you take that massive pool of capital and you invest it strictly into land and basic industrial machinery. Lathes, drill presses, raw farmland.
Okay, so they are buying the physical means of production.
Right. And then this is the magic part of the math. You let it compound. You aggressively reinvest the profits from that infrastructure back into the fund. You don't touch it. You don't pay out dividends.
You just let it ride.
The source calculates that if that working class fund compounded at standard historical market rates for 70 years, from 1950 to 2020, that specific group of people would today own over 20 million acres of prime farmland and industrial infrastructure outright.
Just from nickels.
Just from nickels. That is the terrifying power of compounding capital over time. The working class historically misses out on this because they can't organize at that scale to make the initial investment. They spend the nickel today because they need to survive today.
That is just staggering. 20 million acres is, that's the size of South Carolina. It really highlights that the barrier to abundance wasn't a lack of money. We didn't lack the wealth as a society. We lacked the mechanism.
We lacked the coordination and the organization for that kind of collective decentralized investment.
Yeah.
It illustrates perfectly that abundance was always physically achievable.
Yeah.
We just didn't take that path as a society. We didn't bifurcate our economy when we had the chance.
So let's say we do take that path right now. We finally organize, we build the SMRs, we get the cheap multi-axis CNCs. What does that new world actually look like on a day-to-day basis? Because the source uses a word to describe it that I think scares some people. Autonomy.
It represents a total shift in global power dynamics. Think about it. If you and your local community can produce your own clean energy, filter your own drinking water, and manufacture your own durable goods, you don't need central government oversight for your survival.
Right.
You don't need to rely on a fragile global supply chain that completely breaks down whenever a single cargo ship gets stuck in the Suez Canal.
It sounds a bit like prepper survivalism, but much cleaner.
Thrivalism, maybe.
Yeah.
But the key difference from that bunker mentality is the relationship with nature. The source actively challenges the assumption that human industry inherently destroys nature. It pushes for this concept of ecological synergy.
This is where they start talking about environmental remediation, right?
Yes. The vision is that these local microfactories aren't just stamping out toasters and car parts. They are actively designed to heal the local environment. It mentions using atmospheric water generation to literally pull moisture out of the air to green arid deserts.
And it specifically talks about a massive reforestation effort using black locust trees. Why black locusts specifically? I had never heard of them.
They are essentially a biological hack for a damaged ecosystem. Black locust trees grow incredibly fast, even in terrible conditions. But more importantly, they are nitrogen fixers. They physically pull nitrogen gas right out of the air and fix it down into the soil through their roots.
Like natural fertilizer.
Exactly. If you have severely degraded land, say an old strip mine or an overfarmed field, you plant these trees. They restore the soil quality incredibly rapidly, preparing the ground for native forests or new agriculture to take hold.
So the idea is that human industrial activity becomes net positive. We aren't just endlessly taking raw materials from the earth anymore. Our industrial output actually adds structural value back to the biosphere.
That is exactly the goal.
Okay, I am going to play the skeptic again here. We have the blueprint, the physics checks out. The necessary technology is either already here or it's very, very close. So why aren't we doing it? Why am I still paying an absolute fortune for my electricity and buying cheap plastic crap that breaks in a month?
Well, this brings us to Section 5 of the document, the obstacles. The source identifies the real enemy here, and it is not the laws of physics. It's our institutions.
You mean regulatory bottlenecks?
Zoning laws, permitting, endless environmental reviews. It's the paperclip maximizer of modern bureaucracy. You can have an SMR completely ready to go, mathematically the safest nuclear reactor ever built, But if the current local regulations say no new nuclear facilities within 50 miles of a city because the law was written in 1974, then you just can't build it.
It takes 15 years just to get a permit to dig a hole for a subway station these days.
Exactly. The source argues that if we actually want this transition, we have to aggressively clear out that regulatory underbrush. But then there is a much darker obstacle, they point out: elite resistance.
Yes. This is where the text gets a little more socio-political.
It does. The source suggests that current elites, and it is important to note, it doesn't necessarily mean some shadowy cabal in a smoke-filled room. It just means the people and corporations currently holding the vast majority of the capital.
Right, the people who benefit from how things are right now.
Exactly. They actively benefit from scarcity. If housing is artificially scarce, landlords get very rich. If oil is scarce, energy companies get very rich.
So if everyone suddenly becomes autonomous and can 3D print their own shoes and generate their own limitless power in their backyard, who buys the mass-produced shoes? Who pays the monthly electric bill?
Precisely. The entire economic model of the last century relies on keeping people as dependent consumers. This post-scarcity blueprint turns them into independent producers. That is a massive existential threat to the current status quo.
So this elite resistance, how does it manifest? As physical shortages?
The source argues it manifests mostly as propaganda, aggressive corporate lobbying to keep open-source tech illegal, or just sheer institutional inertia. You know, the attitude of, this is how we've always done it, so this is how we must always do it.
But the source also points out some very genuine technical risks, too. It's not all just the man holding us down.
Very true. There are massive execution risks, like the skill gap we mentioned earlier. If you drop 1 million advanced CNC machines into a major city, but nobody learns the Lojban-style logic to use them fast enough, they just sit there and become rust.
Or what about material impurities? If we are recycling everything in a closed loop, how do we know the metal hasn't degraded?
Right, or basic quality control. In a highly decentralized system who actually ensures the brake pads you just printed for your family's car are going to work when you hit the pedal at 60 miles an hour.
That is a terrifying thought. If I buy brake pads from a major global manufacturer, I know they have a massive legal compliance department testing them. If I just download the CAD file from a guy named Steve in Ohio, I am putting my life in Steve's hands.
We would need to develop a whole new, decentralized way of thinking about physical safety. We'd need modular fail-safes and automated stress testing equipment that doesn't rely on a central government inspector signing a piece of paper.
So putting this all together, we are looking at a vision of a world where energy could effectively be free, waste could be our most valuable raw resource, and anyone anywhere could build almost anything. It sounds completely inevitable when you look strictly at the physics. Atoms are just atoms. But it feels almost impossible when you look at the politics.
That is the central tension of the entire document. The source ultimately concludes that the scarcity we experience today is largely a social construct. It is not a thermodynamic one. The physical tools, the SMRs, the CNC microfactories, the cognitive education frameworks, they exist or they are well within our immediate reach.
It really is a story of emergence in human agency. It's not about waiting for a politician or a billionaire to come save us. It's about taking ownership of the tools so we can build the infrastructure to save ourselves.
And that is a very powerful narrative shift. It asks us to stop seeing ourselves as just hungry mouths that need to be fed by the system and start seeing ourselves as capable minds that can build a new system.
It really makes you look around the room completely differently. You look at that expensive utility bill in the mail or the rising price of gas, and you realize this struggle, this constant grinding feeling of there not being enough to go around, it might just be a choice we're collectively making.
Or more accurately, a choice our institutions are making on our behalf.
And that leaves us with the lingering implication the source poses at the very end. If the only thing actually stopping post-scarcity is human social inertia and not the laws of physics, how much of our daily struggle for survival is actually necessary?
That is the ultimate question. If the door to the cage is already unlocked, why are we all still sitting inside it?
And it brings up a thought that wasn't explicitly in the text, but I can't shake it. If we do solve physical scarcity, if we never have to struggle for food or warmth again, do we lose our sense of purpose? Are we psychologically addicted to the struggle because it's the only way we know how to find meaning?
That is a whole other deep dive right there.
Definitely something for you to think about the next time you pay your electric bill. Thanks for diving in with us today.
It was a pleasure.